Resolving electrical problems often involves tracing issues back to their source, especially when dealing with existing wiring. In this case, the problem was a neutral to ground short, which was causing the arc fault circuit interrupter, or SI, to trip. The root cause was traced to a pancake box where previous, unprofessional work had been performed. The sloppy wiring had resulted in nicks to the neutral wire, creating an unintended connection between the neutral conductor and the ground. This type of fault is particularly problematic because it can create a path for current to flow where it shouldn't, potentially leading to overheating, fire hazards, and of course, the FSI tripping as it is designed to do. The FSI is a safety device designed to detect arc faults, which are dangerous electrical conditions that can cause fires. They work by monitoring the current flowing through the circuit and detecting any unusual patterns that may indicate an arc. When an arc fault is detected, the FSI quickly trips, cutting off the power to the circuit and preventing a fire. One effective solution involved running a new cable from the junction box, often referred to as a J-box, in the attic to the outlet. This replaced the compromised wiring and eliminated the neutral to ground short. After the new cable was installed, the electrical system was tested to ensure that it was functioning correctly and safely. Fixed bid jobs, where the price is agreed upon beforehand, can be risky, especially when dealing with existing wiring. It can be difficult to accurately assess the condition of the wiring and anticipate potential problems until the work begins. Hidden issues, such as damaged wires, improper connections, or code violations, can significantly increase the time and effort required to complete the job, potentially leading to financial losses for the electrician. Therefore, it's important to carefully inspect the existing wiring and consider potential risks before agreeing to a fixed bid. If the condition of the wiring is unknown or questionable, it may be prudent to propose a time and materials-based contract instead, which allows for flexibility in pricing based on the actual work required. When working with electrical systems, safety is paramount. Always de-energize the circuit before working on any wiring. Use appropriate personal protective equipment, such as gloves and eye protection. Follow the National Electrical Code, or NEC, and local electrical codes to ensure that the work is performed safely and correctly. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Troubleshooting electrical problems requires a systematic approach. Firstly, start by gathering information about the problem. Secondly, ask questions such as what happened, when did it happen, and what were the circumstances surrounding the problem. Thirdly, visually inspect the wiring and devices for any signs of damage, such as burnt wires, loose connections, or cracked components. Fourthly, use a multimeter to test for voltage continuity and resistance. Fifthly, check for any ground faults using a ground fault tester. Sixthly, isolate the problem by systematically disconnecting parts of the circuit until the fault is found. Seventhly, once the fault is located, repair or replace the damaged components. Eighthly, test the circuit to ensure that it is working properly and safely. Ground faults can be particularly tricky to troubleshoot because they can be intermittent and difficult to locate. A ground fault occurs when current flows from a live wire to ground through an unintended path. This can happen if a wire is damaged, a device is faulty, or there is moisture present. Ground faults can be dangerous because they can cause electric shock and fires. The NEC provides guidelines for wiring and grounding to minimize the risk of ground faults. These include using properly sized conductors, grounding all metal enclosures, and using ground fault circuit interrupters, or GFCIs, in areas where there is a risk of moisture. Electrical codes, such as the NEC, are designed to ensure the safety of electrical installations. These codes specify the requirements for wiring, grounding, overcurrent protection, and other aspects of electrical systems. It's important to be familiar with the NEC and local electrical codes to ensure that the work is performed safely and correctly. Failure to comply with electrical codes can result in fines, penalties, and even legal liability. Working with electrical systems can be challenging, but it can also be rewarding. By following safety precautions, using a systematic approach to troubleshooting, and being familiar with electrical codes, you can safely and effectively resolve electrical problems. Remember, if you are not comfortable working with electricity, it's always best to hire a qualified electrician. They have the knowledge, skills, and experience to safely and correctly perform electrical work. They also have the necessary tools and equipment to diagnose and repair electrical problems. By hiring a qualified electrician, you can protect yourself, your family, and your property from the dangers of electricity. When working on electrical systems, always remember to prioritize safety. Firstly, always to energize the circuit before working on any wiring. Secondly, use appropriate personal protective equipment, such as gloves and eye protection. Thirdly, follow the NEC and local electrical codes. Fourthly, if you are not comfortable working with electricity, hire a qualified electrician. By following these safety precautions, you can minimize the risk of electrical shock, fire, and other hazards. Electrical work should be performed with precision and care. Sloppy wiring can lead to a variety of problems, including short circuits, ground faults, and overheating. Always ensure that connections are tight and secure, that wires are properly insulated, and that the wiring is installed according to code. Taking the time to do the job right the first time can save you time, money, and headaches in the long run. Understanding the basics of electrical theory can be helpful when troubleshooting electrical problems. Electrical theory explains how electricity flows through circuits, how voltage, current, and resistors are related, and how electrical components function. By understanding these concepts, you can better diagnose and repair electrical problems. There are many resources available to learn about electrical theory, including textbooks, online courses, and workshops. Continuous learning is essential in the electrical field. Electrical technology is constantly evolving, with new products, techniques, and codes being introduced regularly. To stay up to date, it's important to participate in continuing education courses, attend industry conferences, and read trade publications. This will help you maintain your skills and knowledge and provide the best possible service to your clients. When dealing with existing wiring, it's important to be aware of the potential for hidden problems. Previous owners or contractors may have made modifications to the wiring that are not up to code or that are simply unsafe. These hidden problems can be difficult to detect, but they can pose a significant safety hazard. Therefore, it's important to carefully inspect the wiring and be prepared to address any problems that you find. When running new cable, be sure to use the correct type and size of wire for the application. The NEC specifies the requirements for wire size based on the ampacity or current carrying capacity of the circuit. Using undersized wire can cause overheating and potentially lead to a fire. Also, be sure to use the correct type of insulation for the environment. For example, an M cable is suitable for dry indoor locations, while UF cable is suitable for wet locations. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electric shock. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors. Always ensure that electrical systems are properly grounded to protect people and property from the dangers of electricity. When installing outlets and switches, be sure to follow the manufacturer's instructions and the NEC. Outlets and switches must be properly wired and grounded to ensure safe operation. Also, be sure to use the correct type of outlet or switch for the application. For example, GFCI outlets are required in bathrooms, kitchens, and other areas where there is a risk of moisture. Overcurrent protection, such as circuit breakers and fuses, is designed to protect electrical circuits from overloads and short circuits. When the current in a circuit exceeds the rated capacity of the circuit breaker or fuse, it will trip, cutting off the power to the circuit and preventing damage to the wiring and equipment. The NEC specifies the requirements for overcurrent protection, including the size and type of circuit breakers and fuses. Always ensure that electrical circuits are properly protected with overcurrent devices. Electrical panels, also known as load centers or breaker boxes, are the central distribution point for electricity in a building. Electrical panels contain circuit breakers that protect individual circuits from overloads and short circuits. Electrical panels must be properly sized to accommodate the electrical load of the building. The NEC specifies the requirements for electrical panels, including the size and number of circuit breakers. Always ensure that electrical panels are properly sized and installed. When working on electrical panels, be extremely careful. Electrical panels contain live parts that can cause serious injury or death. Always energize the panel before working on it and use appropriate personal protective equipment. If you are not comfortable working on electrical panels, hire a qualified electrician. The use of appropriate tools is essential for safe and effective electrical work. Use insulated tools to protect yourself from electric shock. Use wire strippers to properly strip insulation from wires. Use crimpers to make secure connections. Use a multimeter to test for voltage, continuity, and resistance. By using the right tools for the job, you can ensure that the work is performed safely and correctly. When terminating wires, be sure to make a solid connection. Loose connections can cause overheating and potentially lead to a fire. Use wire connectors such as wire nuts or terminal blocks to make secure connections. Always twist the wires together tightly before installing the connector and ensure that the connector is properly sized for the number and size of wires. When installing lighting fixtures, be sure to follow the manufacturer's instructions and the NEC. Lighting fixtures must be properly wired and grounded to ensure safe operation. Also, be sure to use the correct type of bulb for the fixture. Using the wrong type of bulb can cause overheating and potentially damage the fixture. When working with three-way switches, be sure to understand the wiring configuration. Three-way switches allow you to control a light fixture from two different locations. The wiring for three-way switches can be complex, so it's important to understand the basics before attempting to install them. There are many resources available to learn about three-way switch wiring, including diagrams and tutorials. When troubleshooting electrical problems, it's often helpful to use a process of elimination. Start by checking the simplest things first, such as the circuit breaker or fuse. Then systematically check the wiring and devices until the problem is located. By using a process of elimination, you can quickly and efficiently identify the source of the problem. When dealing with aluminum wiring, be extra cautious. Aluminum wiring was commonly used in homes built in the 1960s and 1970s, but it can pose a fire hazard if not properly maintained. Aluminum wiring expands and contracts more than copper wiring, which can cause connections to loosen over time. Loose connections can cause overheating and potentially lead to a fire. If you have aluminum wiring in your home, it's important to have it inspected by a qualified electrician. They can recommend solutions such as replacing the aluminum wiring with copper wiring or installing special connectors that are designed for use with aluminum wiring. When working with knob and tube wiring, be extremely careful. Knob and tube wiring is an older type of wiring that was commonly used in homes built before the 1940s. Knob and tube wiring is not grounded, and it can be a fire hazard if not properly maintained. If you have knob and tube wiring in your home, it's important to have it inspected by a qualified electrician. They can recommend solutions such as replacing the knob and tube wiring with modern wiring. When working with underground wiring, be sure to call before you dig. There may be underground utilities, such as gas lines, water lines, and electrical lines in the area. Digging into these utilities can be dangerous and can cause serious damage. Before you dig, call 811 to have the utilities located and marked. This will help you avoid damaging them and stay safe. When working with low voltage wiring, such as doorbell wiring or thermostat wiring, be sure to use the correct type of wire and connectors. Low voltage wiring is typically smaller gauge than standard voltage wiring, and it requires special connectors. Using the wrong type of wire or connectors can cause problems with the system. When working with smart home devices, such as smart thermostats or smart lighting, be sure to follow the manufacturer's instructions. Smart home devices often require special wiring and configuration. Using the wrong wiring or configuration can damage the devices or cause them to malfunction. When working with solar panels, be sure to follow the manufacturer's instructions and the NEC. Solar panels generate electricity even when they are not connected to the grid. It's important to take precautions to avoid electric shock when working with solar panels. When working with electric vehicles, be sure to follow the manufacturer's instructions and the NEC. Electric vehicles require special charging equipment, and it's important to install it correctly. Using the wrong charging equipment can damage the vehicle or cause a fire. When working with generators, be sure to follow the manufacturer's instructions and the NEC. Generators generate electricity, and it's important to take precautions to avoid electric shock. Also, be sure to properly vent the generator to prevent carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be deadly. When working with swimming pools, be sure to follow the NEC and local codes. Swimming pools require special electrical grounding and bonding to prevent electric shock. Also, be sure to install GFCI outlets near the pool to protect people from electric shock. When working with hot tubs, be sure to follow the NEC and local codes. Hot tubs require special electrical grounding and bonding to prevent electric shock. Also, be sure to install GFCI outlets near the hot tub to protect people from electric shock. When working with electric fences, be sure to follow the manufacturer's instructions and the NEC. Electric fences are designed to deliver shock to deter animals. It's important to install them correctly to avoid injuring people or animals. The NEC Table 310.15 provides guidance on opacity of conductors. Always consult the latest version of the NEC for the most up-to-date information. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, hire a qualified electrician. They have the knowledge, skills, and experience to safely and correctly perform electrical work. In summary, tackling electrical issues, particularly in existing setups, demands a meticulous approach. Prioritize safety, adhere to codes, and when uncertain, seek expert assistance. A systematic method combined with continuous learning ensures efficient and secure solutions.